Welcome to the discussion. Today we're delving into a research paper titled Mixed Data or Merge Models, Optimizing for Diverse Multitask Learning. This paper explores optimizing diverse multitask learning in large language models, LLMs, focusing on the trade-off between safety and general performance, particularly within a multilingual context. Let's start with the core problem addressed. What are the limitations of traditional multitask learning approaches in LLMs, especially concerning safety and multilingual applications?
Traditional multitask learning often involves training on mixed data sets containing various tasks and sources. However, this approach faces challenges in balancing the objectives. Optimizing for safety, for instance, can negatively impact general performance. Furthermore, safety measures often overfit to biases present in predominantly Western-centric datasets, failing to generalize to multilingual settings where unique linguistic structures and cultural nuances introduce further complexities. The paper investigates whether model merging offers a superior alternative.
The paper proposes model merging as a solution. Can you elaborate on the different model merging techniques explored and their underlying principles?
The paper compares four merging techniques: linear merging, simple weighted averaging of model parameters; spherical linear interpolation, SELRP, interpolating weights along the shortest path on a high-dimensional sphere; ties merging, addressing parameter interference and sign conflicts; and DARE ties, building upon ties with dropout applied to delta parameters. Each method aims to combine the strength of models trained on different datasets. For example, one focused on safety, another on general tasks or languages, while mitigating potential weaknesses.
The paper contrasts mixing data with merging models. What were the key findings regarding the relative effectiveness of these two approaches?
The study found that model merging consistently outperformed data mixing in balancing safety and general performance. Merging yielded improvements of up to 8% in general performance and 10% in safety compared to data mixing. This suggests that combining pre-trained models optimized for specific objectives is more effective than training a single model on a mixed dataset.
The research also investigated the impact of merging on multilingual capabilities. What were the results of merging monolingually fine-tuned models?
Merging monolingually fine-tuned models, each trained on a mix of safety and general data in a single language, proved highly effective. This approach achieved a 4% increase in general performance and a 7% reduction in harm across all languages, surpassing the performance of the data mixtures method using the same data. This highlights the potential of merging for managing the dual challenges of safety and multilinguality.
The paper mentions several ablations. Can you highlight the most significant ones and their implications?
Key ablations included comparing objective-based merging models optimized for different objectives versus language-based merging models trained on different languages, analyzing the impact of merging on SFT, supervised fine-tuning, versus DPO, direct preference optimization, checkpoints, and investigating the sensitivity of merging algorithms to hyperparameters, particularly the weighting scheme in linear merging. These ablations provided a comprehensive understanding of the strengths and limitations of different merging strategies under various conditions.
The paper uses specific benchmarks for evaluation. Can you briefly describe the metrics used to assess safety and general performance?
Safety performance was measured using the IA-RED teaming dataset, focusing on the relative percentage change in harmful model generations compared to a baseline model. General performance was evaluated using the multilingual DALI 200 val set, measuring absolute win rates against the baseline. Both evaluations utilized an LLM as an evaluator approach with GPT-4 as the judge.
The results showed varying degrees of success across different languages. Were there any notable patterns or inconsistencies observed?
While merging generally improved performance across languages, the optimal merging technique and the magnitude of improvement varied. Some languages benefited more significantly than others from specific merging methods, suggesting that the effectiveness of merging might be influenced by factors such as language family, data availability, and the inherent characteristics of the language itself.
The paper also explored the impact of the safety model weight during linear merging. What insights did this ablation provide?
Increasing the weight of the safety-focused model during linear merging significantly improved safety performance, even with relatively low weights. However, this came at the cost of reduced general performance. This highlights the trade-off between safety and generalizability and the importance of finding the optimal balance through careful hyperparameter tuning.
The paper investigated the interplay between merging and continual preference training using DPO. What were the key findings from this aspect of the research?
The results indicated that performing preference tuning after star merging yielded better alignment compared to tuning before merging. This suggests that merging can be effectively integrated into a continual learning pipeline, with post-merge fine-tuning further enhancing the model's safety and performance.
How does this research compare to existing work on model merging and multilingual safety?
While previous research has explored model merging for improving general performance and has addressed multilingual safety challenges separately, this paper uniquely combines both aspects in a comprehensive study. It investigates the effectiveness of merging for balancing safety and general performance across multiple languages, offering a novel approach to building robust and safe multilingual LLMs.
What are the key takeaways and potential implications of this research for the field of LLM development?
The key takeaway is that model merging offers a promising alternative to data mixing for optimizing diverse multitask learning in LLMs, particularly in multilingual settings. This approach can effectively balance safety and general performance, leading to more robust and reliable models. The findings highlight the importance of considering different merging techniques and their sensitivity to hyperparameters when designing training pipelines.
Are there any limitations to the study or areas for future research?
The study focused on a specific set of languages and merging techniques. Future research could explore a wider range of languages and merging methods, investigate the impact of different pre-training models, and delve deeper into the reasons behind the varying performance across languages. Furthermore, exploring the scalability of merging to even larger numbers of models and tasks would be valuable.
This has been a very insightful discussion. Thank you for sharing your expertise on this important research.